Hello class, in this video we're going to talk about exponential functions and how they apply in the real world, specifically to the financial world. So the formula you're going to be using today is A equals P, get that, there we go, times 1 plus R divided by N to the power of N times T. So let's talk about this. Suppose Quan Lee invests $500 at 7% compounded annually. Find the value of her investment 10 years later. So we got P is your principal. That's always your starting amount of value. We went over that with other forms of exponential functions. P will always be your starting value. Your rate is R, and that's the percentage. And then obviously years is T, that's time. Now the N is how many times it's compounded. This is how much you are splitting your rate over the course of the year. Now, if you're doing it annually, and it's over the course of 1 year, then this would be N equals 1. So let's set it up. We got 500 times 1 plus 0.07 divided by 1 to the power of 1. These two N's are the same, times 10. Now, at this point, you can type this in your calculator. I would do something similar to what I recommend for half-life. I'm going to do this exponent first. So that's going to be 500 times 1 plus 0.07 divided by 1 to the power of 10. 1 plus 0.07 divided by 1 to the power of 10. We get $983.58. Okay. So suppose Roberto invests $500, 9% compounded monthly. Find the value of his investment 12 years later. So we've got $500 for our principal, and then 1 plus 0.09 divided by monthly. How many times will that happen over the course of a year? Well, there's 12 months in a year. And then we've got 12 times 12 in the exponent. I'm just going to write that out now. 12 times 12 is 144. And we'll go from there. 500 times 1 plus 0.09 divided by 12, power of 144. $1,466.42. There we go. Suppose Roberto invests $500 at 9% annual interest compounded monthly. How long will it take for his investment to grow to $3,000? So now we're doing it a little bit differently. We're going to set $3,000 as our future value. Okay. We have $500 as our principal. Our rate is 9%, and then compounded monthly. That's 12. Now we're looking for T, so our exponent would just be 12 times T. Okay. Let's go ahead and solve this algebraically. We get divided by 500. We get 6 equals, I'm going to go ahead and get 1 plus 0.09 divided by 12 is a decimal. 1.0075. 0.0075 to the power of 12t. And you guessed it, we're going to use the logarithm. Okay, so this brings it out. And then I'm going to save myself a little bit of room. I'm going to divide natural log of 6 by natural log of 1.0075. So natural log of 6 divided by natural log of 1.0075. That would be interesting. 239.1 we'll say 796 equals 12t, and then divide by 12. And you get 19.98. So t is approximately 19.98 years. Stephen has $500 to invest. What annual interest rate, compounded quarterly, is required to double his money? So doubling would mean we'd want 1,000. Because we start with 500. Now we're solving for R. And compounded quarterly, you can always think 4 quarters in a dollar. And then 10 years. So this would be to the power of 40. So once again, we'll start by dividing by 500. We get 2 equals, this is 1 plus R divided by 4 to the power of 40. And then we'll go ahead and take this to the exponent of 1 over 40. And right now, I think I'm just going to leave this as 2 to the power of 1 over 40. Give myself a better answer at the end. Let me clean that up a little bit. Divided by 40, there we go. And so then these cancel out, and we're just left with 1 plus R divided by 4. And then ignoring the exponent, it's clearer to see what we do. We're going to subtract 1, and then we're going to multiply by 4. So I'm going to do that on my calculator. I'm going to do 2 to the power of 1 divided by 40 minus 1. And then we get 0.0017, something like that. And then we multiply by 4. We get 0.0699. So it's about 6.99% is our rate. Suppose Latasha invests $100 compounded 8% at 8% compounded continuously. What will her investment be at the end of 5 years' time? So this is a separate formula, and it's PERT, and your E is your exponential function. So you'll need to find your E on your calculator. It's usually right around where the logarithm is. If you find the logarithm button, usually with the natural log, you just need to press the button. Whereas with the E to the X, you press second in the button. So we got $100 times E to the 0.08 to the power of 5. And I can do this, so it's 0.08 times 5 should be 0.4. Yeah. So we got 100 times E to the 0.4 power. We get $149.18. All right, so our annual percentage yield is a method of trying to compare multiple investment opportunities. So K is the number of times compounded. In the formula in the book, they use K instead of N on this. I don't know why. And then R is our rate. So I actually won't write anything on this slide. Okay. So let's go over a problem. Ursula invests $200,000 at Crab Key Bank at 5.15% quarterly interest. What is the annual percentage yield? Sorry, this isn't to compare. I think I misspoke. I think I'm thinking of a different formula. The annual percentage yield is what does the interest rate end up being over the course of the year? Because while you're given an interest rate, you are dividing it up over the course of the year. And so if you were to use it, it's basically what it does. It compares it to what's the actual interest rate if you compounded annually. So let's go with Now the principal is irrelevant. We have 0.0515 divided by 4 for compounded quarterly. And the reason why time doesn't make a difference is because it's annual. It's only going to be 1 year, and it doesn't matter how much you're investing. So type that into your calculator: 1 plus 0.0515 divided by 4 to the power of 4, and then all minus 1, and we get 0.0525. So this is basically saying if I wanted an equivalent rate that is compounded annually instead of quarterly, I would need a rate of 5.25%. Thanks for watching.